All right, good morning, everybody. Today's lesson will be what about exponents with different bases, okay? So we're going to explore exponent patterns with bases other than 10. So instead of doing 10 to the something, what about 2 to the something? 6.1, true or false? Is each statement true or false? Be prepared to explain your reasoning. So first, you want to be able to figure out what is 3 to the 5th or 4 to the 6th, because you want to know which one's bigger. Now, I'm going to give you a little hint. 4 is the same thing as 2 squared. So 4 to the 6th is the same thing as 2 squared to the 6th, which is 2 to the 12th. Okay? So another way to think about this is 3 to the 5th or 2 to the 12th. Now, I can assure you 3 to the 5th is 81 times 3. Because 3 times 3 is 9. 3 times 3 is also 9, so 9 times 9 is 81. And 81 times 3 is 243. Now, I already know 2 to the 10th is 1024. And if you're multiplying it by 2 twice, obviously it's going to be true. This is bigger. So this is true. -3 quantity squared. This is -3 times -3, which is a positive 9. 3 squared is 3 times 3, which is 9. So is 9 bigger than 9 or is 9 equal to 9? Yup, 9 is equal to 9. So this is false. This is not the correct symbol we need here. -3 to the third power is -3 times -3 times -3, which 3 times 3 times 3 is 27. Oh my God. Jesus. But a negative times a negative times a negative is a negative. And then 3 times 3 times 3, well, that's 27, which is false. Positive 27 does not equal negative 27. And then last but not least, -5 squared, well, that's -5 times -5, which is positive 25. And then this, some of y'all might get tricked out. This is actually -5 times 5. The negative, bro, did I not put this in? Why am I getting messages? Maybe I have to go on my phone as well and put it on Do Not Disturb. Sure. Okay. -5 times 5 is -25. So obviously 25 is bigger than -25. So this is true. Okay? So what happens with 0 and negative exponents? Complete the table to show what it means to have an exponent of 0 or a negative exponent. So, what happens as you multiply by 2? Well, if you go in the what is wrong with that dude? If we multiply by 2 going one direction, we have to divide by 2 going in the other direction, okay? So, dividing by 2, 16 divided by 2, let me zoom in, is 8. Dividing by 2, 4. Dividing by 2, 2. Dividing by 2, 1. 1 divided by 2 is technically 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. What is wrong with that guy? 1/8 divided by 2 is 1/16. And so on. If you notice, the denominator is doubling, but also, it's just the same thing as what we had. except it's in fractional form. And then this is 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4. So as you're going that direction, you're multiplying by 2. That is, you're going that direction, you are technically multiplying by 1/2. Okay? As you move toward the left, each number is being multiplied by 2. What is a multiplier as you move to the right? 1/2. Use the patterns you found in the table to write 2 to the negative 6 as a fraction. Well, that's just going to be 1 over 2 to the 6th. Write 1 over 32 as a power of 2 with a single exponent. Well, first of all, let me go over here. 32 is 2 times 2 times 2 times 2 times 2. So how many 2's do we have? 5. But then 1 over 32 means 1 over 2 to the 5th, which is 2 to the negative 5th. Okay? Awesome possum. What is the value of 2 to the 0? Oh, I hope you know this. Let me just highlight it. What's 2 to the 0? Uno. And from the work we've done with negative exponents, how would you write 5 to the negative 3 as a fraction? Well, remember, it has a negative exponent, so we're going to do a reciprocal 1 over 5 to the 3rd. And then how would you write 3 to the negative 4 as a fraction? 1 over 3 to the 4th. But if I really want to put power into it, 1 over 3 to the 4th. Are you ready for more? Heck yeah! Find an expression equivalent to 2/3 to the negative 3rd, but with positive exponents. Okay, so we want to write 2 over 3 to the negative 3. So first things first, if we want to change the negative into a positive, we have to take the reciprocal of the fraction. The reciprocal of the fraction is just the flipped version, okay? So that's going to be 3 over 2. And then you convert the negative 3 to a positive 3. Not that bad, right? You just flip them. So what about number 2? Find an expression equivalent to 4/5 to the negative 8. You're going to flip it and then convert to a positive. What patterns do you notice when you start with a fraction to a negative power and rewrite it so that it only has a positive power? You flip the fraction and change the exponent into a positive. Len, Noah, Diego, and Elena decide to test each other's knowledge of exponents with bases other than 10. They each chose an expression to start with and then came up with a new list of expressions, some of which are equivalent to the original and some of which are not. Choose 2 lists to analyze. For each list of expressions you choose to analyze, decide which expressions are not equivalent to the original and be prepared to explain your reasoning. Well, you know what? Let's just use the first 2. So her original one is 5 to the negative 9, okay? So here, what do? We're taking an exponent of an exponent. Yep, we multiply them. So 3 times negative 3 is negative 9. That works. this does not work because this is technically negative 5 times 5 times 5, 9 times, which is different. I'll put an X. 5 to the negative 6 over 5 to the third. If we're dividing exponents, what do? We subtract them. So this is 5 to the negative 6 minus 3, which is 5 to the negative 9. We're taking a power to a power, so what do? Yep, we multiply them. So that's going to be 5 to the 3 times negative 2, which is 5 to the negative 6, not negative 9. 5 to the negative 4 over 5 to the negative 5. We're dividing exponents, so what do? You subtract them. It's a plus plus, so this means it becomes a negative 4 plus. Sorry, it's a minus minus, so it becomes a plus. So that's 5 to the 1. And last but not least, 5 to the negative 4 times 5 to the negative 5th. Since we're multiplying, we're going to add the exponents. It's going to be 5 to the negative 9. Noah's original expression is 3 to the 10th, okay? Are we going to multiply or add the exponents? Yep, we're going to add them. So 3 to the 5 plus 2 is equal to 3 to the 7th. Nope. 3 to the 5th squared. We're going to multiply the exponents. So that's going to be 3 to the 5 times 2. That's 3 to the 10th. Put a star to it. Ooh, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 3 to the 10th. Oh, pues. Big oof. That's fine. Okay, so this is going to get confusing, but it's not that bad. So we have 1/3, and we're taking it to the negative 10th. Remember, if we have a negative exponent, whatever's inside the parentheses, you flip it, okay? So 1 over 3 becomes 3 over 1 to the 10th. But what's 3 over 1? Yep, it's 3. So that's just 3 to the 10th. 3 to the 7th times 3 to the 3rd. What do we do with the exponents? We add them. So 3 to the 7 plus 3 is 3 to the 10th. Three to the 20th over 3 to the 10th. We're dividing the exponents. So what do? We subtract them. Yes. So 3 to the 20th minus 10. That's 3 to the 10th. And what is this going to be? That's supposed to be a 3 to the 18th. Since we're dividing, we subtract the exponents, so 20 minus 2 is 18. Now, if you want to go above and beyond and test your knowledge, you can do these, okay? Nothing wrong. But today's lesson is just to solidify those rules, all those rules that we've been practicing this week and before we went on break. All those rules can apply to powers of 10 and other bases. The base doesn't have to be 10. It could be 2, it could be 3, it can be 7, it could be 9. I'll even tell you a little secret. You can do these with negative numbers, even decimals, okay? There's no limit as to what your base can be. Except 0. Can't be 0. Okay? So let's take a look at the practice problems, okay? Priya says, I can figure out 5 to the 0 by looking at the powers of 5. 5 to the third is 125, 5 squared is 25, and 5 to the first is 5. What pattern do you notice? Well, if you multiply by 5, the exponent grows bigger, but what's the opposite of multiplying? Yep, dividing, right? Dividing by 5. So if you divide 5 by 5, it does equal 1. Sorry, you can figure out what 5 to the 0 is. Oops. You are multiplying by 5. So if this pattern continues, what should be the value of 5 to the 0? 1. Because 5 divided by 5 is 1. If this pattern continues, what would be the value of 5 to the negative first? Well, we already know from the lesson that's just going to be 1 over the 5. But technically, you would take this number here and divide it by 5. And we know that's the same thing as 1/5. Select all expressions that are equal to 4 to the negative third. So I'm just going to rewrite this as 4 over 3, which I know, because I'm a math nerd, is 1 over 64. Well, it's definitely not negative 12. 2 to the negative 6, let's see. This would be 1 over 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2. I know 2 to the 5th is 32. So this is 1 over 32 times 2, 1 over 64. Yep. I'm going to highlight it blue just to make it easier. And sure enough, 1 over 4 to the third. That's also true. 1/4 times 1/4 times 1/4 is... Yes, I hear you. You know you in Oakland. 1 times 1 times 1 is 1. 4 times 4 times 4 is, well, that's just 4 to the third. So again, it's equivalent. 12. No. Negative 4 times negative 4 times negative 4. Nope. Let me say this again. Negative exponents does not mean negative answers. Okay? This is actually equal to negative 64. And then this, let's see. 8 to the negative first, well, that's going to be 1 over 8 times 1 over 2 squared. That's 1 over 8 times 1 over 4, 1 over 32. Nope. Write each expression using a single exponent. 3 minus 6 is negative 3, so that's going to be 5 to the negative 3 power. We're taking an exponent to an exponent, so we're going to multiply. 3 times 6 is 18. We're multiplying the exponents here, so we're going to add them. 3 plus 6 is 9. We're dividing, so we're going to subtract the exponents. 6 minus 3 is 3. And then we're taking an exponent to an exponent. So what's 3 times negative 6? Negative 18. Okay? Andre sets up a rain gauge to measure rainfall in his backyard. On Tuesday, it rains on and off all day. He starts at 10 a.m. with an empty gauge when it starts to rain. So it's empty. Okay? So if it's empty, it can't be this one. 2 hours later, he checks, and the gauge has 2 centimeters of water in it. Wait, what? Okay. After 2 hours, there's 2 centimeters. That makes sense. It starts raining even harder, and at 4 p.m., the rain stops. And Andre checks the rain gauge and finds it has 10 centimeters of water in it. Okay, that kind of makes sense. At 4 p.m. Okay, graph A. So this would be time in hours, and this would be water in centimeters. Use a graph to determine how much total rain fell on Tuesday. It's a very good question. How much rain fell on Tuesday? Okay. So, to me, from when he first started recording till 4 p.m., there was a total of 10 centimeters of rain. But then homie knocked it, and there was no more rain after that. So the total amount was 10 centimeters of rain. And it's raining right now. I hope you're enjoying these lessons. I'm starting to feel a little bit under the weather. I was doing a lot of singing the other day, and I started moving a lot of stuff at my place, so there was a lot of dust. Might be getting allergies. Let's hope. Let's cross your fingers, right? That's me crossing my fingers. Nonetheless, yeah, please click submit, subscribe, like my video, share it, whatever YouTubers say nowadays.